Hey guys, Dexter here from Dexter's Workshop. Today I've decided to show you a little bit on fast forward some some things that you might find useful in case you are milling your own PCBs, and that would be the fact that you can actually simulate the whole process. And you can see if something goes wrong, if you have enough clearance and stuff like that. Basically, what I'm doing here, I took a previous design of mine, and we are going to mill only the top layer. So, first thing you will have to do is go on and plot the Gerber files. And as I said, we are going to mill only the top layer. Well, we are going to simulate actually the edge cuts remains. Okay, the output directory will be something in a temporary file. Let's see. GRBL TMP. Okay. Select. No, we don't want that. So top and the edge cuts. What are we going to do now is going to plot. Okay, files created. We are going to generate the drill files in millimeters, and we are going to plated and non-plated holes in the same zone next column. Okay, generate drill file. Okay, file generated. So at this particular moment you have two files. One is a Gerber file, one is the drill file. A tool that you'll need to use is FlatCAM. Basically, what you can do here is import Gerber files into this tool, and actually it will make tool path and necessary adjustments. So we're going File, Open Gerber, going to, let's see, Gerber TMP. Now we can go with top. Okay, what we'll need is Open Gerber, and we'll need the cuts, the edge cuts, so we can have this, and excellent files, which is the DRL. As you can see, okay, selected. I like to have them solid. Okay, next thing you will have to do, because it's much safer, it's have your origin pointing out to approximately 0.0, and you are doing this by clicking on a little bit outside your PCB. Just click and press Ctrl C. Just copy. And for each gerbil, you will need to adjust the offset. So the vector offset here. Now, because it's an offset, please keep in mind that you will have to inverse the sign of the coordinates. So which is positive, you'll have to make it negative, and which is negative, you'll have to make it positive. In this case, I'm going to just copy this because I just modified. I click offset, and then I'm going to offset, and I'm going to offset everything into a 0.0 point. It's much easier for any machine to work basically from a 0.0 point. Okay, so as you can see, basically we are in the 0.0 ballpark. Okay, for each Gerber layer, you'll have to generate toolpath, and that would be, but this is a demonstration purpose only, and that will be according to your tool specification, etc. So tool diameter, usually you will have to check out options. At project options, you'll have to see if millimeters it's selected. Okay, usually tool diameters are 0.1 millimeters. Uh, passes, I usually like to use 3 passes with an overlap of 50%. Okay, so each pass will overwrite the previous one by 50%. For each pass, it will generate basically a file, a toolpath. So for each pass. So if you want to have the same file with the all 3 passes, you'll have to combine passes, generate geometry, and you will see that the geometry is generated according to your specification. Keep in mind that this is only the geometry, it's not the toolpath yet. So for each one, we will generate basically the same thing. 0.1, 3 passes using a 50% combined passes, generate geometry. As you can see, we also have the edges of the board milled. Another thing you'll have to do is select the board cutout, and that would be in case you are using a frontal bit or a cut bit. You will have to put the diameter. I'm usually using a 3 millimeter bit. Margin, the left margin will be 0.1 millimeter, and the gap size. The gap size in millimeters will be how much gap for the fixing the board will be left. So I like to have 5 millimeters. Generate geometry, and you will see here that is the gap that I was talking about, from here to here. Basically, when the bit will go on and cut this geometry, here we'll leave the those fixing points of 5 millimeters, so the board will not fly off. Okay, so we have generated the geometry. Another thing, you'll have to generate the drill cut Z. Here you will have to you'll have to put the thickness of your PCB, which is a standard 1.6. The travel Z is how much from the surface of your PCB will the Z-axis will go up to ensure clearance when it will travel to another point. So here I like to have at least 2 millimeters. Feed rate, that's according to your machine specification, and that would be, I don't know, I'm using 50 millimeters per second. I would like to have tool change, and tool change Z, it's the distance for at which the Z-axis will travel when you have to change the bit. And I like to have it a little bit higher than the dimension of the bit, so I will not be forced to make a lot of moves and stuff like this. So usually I'm putting here 20 millimeters. So the Z-axis will have to go up 20 millimeter, wait at that particular point, I will change the bit, and then I'll press start again or resume, and everything will be taken from that point. Okay, that's about it. You can use the generate button, and it's generated. Okay, the drill file will not need any more modifications. You will have you can actually export it as it was generated, and as you can see, the toolpath is already displayed on the PCB. Okay, another thing you'll have to do, you have ISO, and the cutout. Basically, what's isolation, what's underscore ISO, it's the milling that will take place and the isolation milling that will take place for your PCB, and you can actually go on edit and join geometry, so you will have only um, one file that will include the all isolation geometry. Here, you will have to actually uh, insert the depth of the depth of the copper. So usually I put 0.1. It's more or less in the ballpark. The travel, again, I like to have at least 2 millimeters. The feed rate, as I said, I'm going 50. Tool diameter, it's 0.1. If you would like to have multiple depth, you will have to define depth per pass. If you are going to have multiple depth when you are going to mill it, and you would like to go down each pass with a certain amount, then you'll have to define depth per pass. In this case, it's not necessary. Okay, we are going to generate the CNC object, and it will take a while. CNC job created. We'll have it here. Combo CNC. The cutout, you will have to cut the Z and put it minus to go down minus 1.6 millimeters. Travel, again, around 2. Feed rate 50. Tool diameter, in case I would like to have the cutout, tool diameter will be 3 millimeters. And I think that... Oh, okay. This is the tool path for the cutout. Another thing that I do think that I've made a mistake here. You can always delete the generated files. Cut Z is minus 0.1. Please be careful here. So the cutting Z, it will be negative, not positive, because you want it to go down, not up. The other things are just fine, so we will generate it again. Okay, so we have all the necessary information and the tool path regarding this particular PCB. Okay, next you will have to export the files. You'll have to export the CNC files. And first we are going to export the combo CNC, and that would be the passes for the PCB isolation. And you are going to just select the newly generated CNC toolpath, go select export G-code, and here you can say PCB dot G-code. Okay, we will click save. Another thing that you will have to do is the cuts. Okay, you will need to export also the cuts. Selected, export PCB cut dot G-code. Okay, and next you will have to export the drill files. Selected, export G-code PCB DRL dot G-code. Save. Okay, at this particular moment you will have all the necessary information to start milling your PCB, but as I said, this is not necessarily about milling your PCB, but it's about how can you simulate and ensure that everything is going well. Another thing you'll have to check out is the DRL. As you can see, there is a tool defined here, and that is a tool number and the tool diameter. you'll have to keep that in mind when you are going to uh, make the tool change operation. And in the simulation, you will have to define those tools, uh, and I will show you how. So for the simulation, there's a very nice software that is called Chemotrix, and you will find it to download. You just start it up, and this will actually simulate everything for your Gerber files, and it will ensure that everything is going as smooth as it can be. What we are going to do is going to new project. I'm going to select units are metric, and tool table is the default one. I don't want the current. Okay. First thing I will do is define the tools, new tool, and I'm going back here and I can see the tool number one is 0.6 millimeters. So the tool number one will be millimeters. The profile will be cylindrical. The length of the tool it's almost unimportant, but the diameter will be 0.6. And you click save. Tool number two, add a new tool. Tool number two will be 0.9. 0.9 and also will be cylindrical. And the tool number three will be 1 millimeter. As you can see, the tools are defined only for drilling operations. The tools are defined only for drilling operation. The rest of the tools are going to be implied for the fact that the milling will take place with the same tool. Now, having this made, after this you can actually start and load your CNC file or your G-code file. So you are going to do add file, you are going to load a G-code file, and we're going here, Gerbil TMP. First you would like to go on and load the PCB cut. Okay. Next, add file, G-code. You're going to have the PCB. Add file, G-code, and you are going to load the GRL. Okay. As you can see, you can actually move the actual order of operation is the one that it's written here. So you go cut, PCB G-code, the milling, and after that the drilling. The order of operation, at least as I'm doing it, as I was going to do it, is first I'd like to mill, then I like to drill, and only after that I'm going to cut out the board. I found it quite logical, and you'll save a lot of you'll be saved from a lot of trouble of the board moving and having a lot of stress by being connected only in 4 points. So this is it. After this, you can let the software generate your workpiece with a plus 5% margin, or you can actually go manual and generate choose the dimensions yourself. First, you have to run the simulation, and that will going and show you all the tool path that is going to be used. Okay, then you can go manual and you can actually change the stock value. That would be the dimension of your copper clad. I'm going automatic because I don't have any problems with that. If you're going to go manual, be sure you're here you can put 1.6 millimeters, and here the offset will be minus 1.6 millimeters. Okay, run it again, and as you can see, the thickness of the material changed. At this particular point, all you have to do is press play, like this, and you will see the G code, the tool position, okay, and also the remaining time, etc. Okay, you can speed the process up because it will actually last some time. You can speed the process up by spinning up toolpath animation, and you can actually go to higher speeds for the simulation, as you can see. And you can actually take a look. And you can speed up the process quite a lot. And after that, you can really go out and see how everything is going to be made by going with the timeline here. So yeah. So this is a good way, a very good way to make the simulation before you are going to cut out your PCB. Hope this I don't know, instructional will help you along the way, and if you like it, give it a thumbs up, and you can always subscribe to my channel. Bye guys, this is Dexter from Dexter's Workshop. Have a nice evening, and always look for new ways of doing stuff. Bye guys, take care.